Hello, everyone. My name is Marcos Serrano. I am Associate Professor at the University of Toulouse in France. And today I want to present the work that I conducted with my colleagues Jolee, Finch, and Roudaut from the University of Bristol, Pourang, Irani from the University of Manitoba, and Andrés Lucero from Aalto University. And in this work, we contribute with an understanding on the rationale of the 4 factors of handheld freeform devices. So let's start with the game. I want you to imagine if you could give any shape to your handheld device, what shape will it be? I'm going to give you some examples of shapes that you could give to your mobile device. So these are real examples of existing mobile devices that are made in China, which have very different shapes, like a skeleton shape, a strawberry shape, or a granite phone shape. So obviously, I just use these funny examples to introduce my research question, which is, what is the rationale for the choice of form factors of handheld freeform devices? And well, now you may be wondering why we focus on freeform handheld devices. Well, actually, we are inspired by previous work on shape-changing devices, which identify how such devices could be handheld. But this previous work specifically focused on the shape transformation itself. We also build upon our initial research on non-rectangular displays, where we already started investigating some initial usage scenarios for such displays, such as road signs, cooktop displays, or handheld devices, among others. So to sum up, compared to those previous works, what we want to contribute now is with an investigation on the rationale for the choice of the different shape features of such devices. So to answer this question, we conducted a 3-steps approach. First, we asked participants to mold, in a first design session, to mold their own handheld display and think aloud about the rationale and perspective behind the various shape features that they selected for such device. We conducted a thematic analysis on the discussion transcripts to identify the emerging themes. And then we conducted a last design session to further study the interlink between dexterity and discoverability. So obviously we have limited time in this video, so I'm just going to talk about the first 2 parts of this approach. And if you want to have more details about our last design session, you can read our paper. So in the first study, we ran 2 design sessions with a total of 12 participants working in pairs. And all of them were HCI students, but had no previous experience in freeform devices. And we basically give them pencils, paper, Play-Doh, and clay and molding tools, as you can see in this image, and 2 specific scenarios for a set of very common tasks. And they were asked to create 1 prototype for each task in each context. So each pair had to create 4 prototypes in total. So here you can see an example of the collected data beyond the discussion transcript. So participants made sketches, clay prototypes, and took pictures of themselves, illustrating how to grasp the devices. So what we did is that we conducted a thematic analysis on the Think Aloud discussions transcripts, and we identified 3 emerging themes, which are the freeform dexterity, the shape features discoverability, and the shape adaptability. So one of the most recurring themes relates to the dexterity, which refers to the ability to hold the device securely while enabling the interaction. 4 subtopics emerge frequently. First, participants clearly identify that there is a trade-off between holding and interacting with a device. Second, they discuss about how certain shapes are better than others at either holding or interacting. And for instance, rounder shapes appear better for holding. Thirdly, they propose solutions involving things such as holds to help achieve both action, so holding and interacting. And finally, they discuss the trade-off between occlusion of the screen and interaction. So occlusion was an important subtheme. The second most recurrent theme concerns the discoverability of how to hold the device. So by discoverability, we mean how the shapes invite users to hold and interact with the device in the correct way without prior instructions. And participants particularly discussed two kinds of solutions for increasing discoverability. First, using metaphors such as this wheel-shaped device on the left, or using shapes where the hand can dock in a certain way. The third theme focuses on how well a given shape adapts to a usage scenario, because participants suggested that one shape cannot fill all functionalities, and that a shape should adapt to either a certain task, user, or context. Participants also discuss how the device shape could increase the practicality or even the impracticality of the device. For instance, this lamp shape that you see on the right was a device that was discussed as something that the user cannot easily put in her pocket, so quite impractical. So to sum up, with this paper, we contributed with a novel understanding of how people choose the shape features on handheld freeform devices, which builds upon our previous work on freeform interfaces. There is obviously many work left to be done to fill the agenda on non-rectangular interfaces and displays, particularly regarding how to interact with such devices or how to adapt the content. Thank you for your attention, and obviously if you have more questions or if you want to know more about our work, please read our paper.